Welcome to Fusion 360 tutorial at Ingis Tech. Today I will design an Omni wheel. So at the beginning I'm starting with a new design, then a fresh sketch. First I will draw three circles regardless of the dimension. Now is the time to assign diameters. So this one gonna be 3 millimeter, quite small. 18, 24 and 60. Now for this circle I will eliminate everything. Small mistake. This circle not supposed to be, this line supposed to be starting from here, so I have to go back, and that's gonna be 45 degrees Celsius, not Celsius, 45-degree angle. 45-degree angle. So 18, 24 and 60 is the radius. 3 millimeter. Now to eliminate all the lines, even the circle. We will use the circular pattern to draw four of them. Okay, this is the frame arm, as you can see, where the roller will be connected. It is not ready yet. Now is the time to make some fillet. 3, again this one 3 millimeter. Then with the midpoint of the circle 2 millimeter. The distance between this and this should be 2 as well. Distance between this and this is gonna be 7. We'll draw a line in between, then a midpoint circle. Midpoint circle 3 millimeter. 135-degree. Another fillet of 7 millimeter. Distance between this and that, 8. Distance between this circle and the center line, the construction line. Okay, the line has not been created yet, so I will create the line this time. It was deleted before. So the distance between this circle should be 23 millimeter. Okay, look like we are all set. Now constraint off, constraint visibility off, dimension visibility off, circular pattern. Before that, I need to eliminate these lines as well. With the circular pattern. Okay, all the lines are selected. Eight of them. Hopefully it will work this time. Let's see. Okay. Good news. It's working. So our Omni wheel metal flange is almost ready. 2 mm extrude. Convert it to the sheet metal. Aluminium 2 mm. Okay. Now another drawing. Okay, so 7 mm and distance 4.95 from the center of the circle. Now finish sketch. We need to go back to the sketch again. Circular pattern, center point, eight of them. No bent part, stationary side, stationary side. Need to choose this part, but somehow it's not choosing this. Not always. Like this one, not choosing. Not this one, not this one. So all of them should be 45 degree. Then we'll go for the second time. I don't know, for some reason it does not want to choose this part, so I'll go one by one. 45 degree this one. Third try. Maybe this is the viewing angle or things like that, I don't know. Let's try again. No. As you can see, it does not always want to choose. I don't know why. If you know the reason, please leave it on the comment. No. Okay, working this time, so 45 degree. Okay, so this is our metal body part for the Omni wheel. We'll give it a name. First, which will convert from body to component. New component. Mm. Omni metal body. Not the appropriate name, but the part is working. So this is the part we have created so far. After assigning the metal property, the color look like this. The next part we'll draw the roller. So new design, sketch. Both of them are construction line. The dimensions for these lines will be this is 1.5, horizontal. Okay, now is the time to mirror this part. Mirror line. Okay, finish drawing and do a revolve. Axis, new component, give it a name, the roller. One millimeter fillet this time. Another 1 millimeter fillet. So our roller is ready. Now I will draw the roller pin here. So for the roller pin, new design again. I'm creating all the components separately, then I will assemble them. So sketch, 7.5, 1.5 extrude, new component, this time another circle, 5 millimeter, extrude, three millimeter extrude. No, too much. 0.5 millimeter extrude. Then sketch again. 2.975, and the last extrude 0.8 millimeter. Name of the part is roller joint. appearance. New sketch for the third part. This part I'm gonna do this time. So which is gonna be 32 mm. 27.5, 18 mm circle this time, 3 mm extrude, W 3 mm extrude here as well, -3, 15 mm circle, and 7 mm extrude, 3 mm circle this time, five mm cut, 3 mm chamfer, the other side of the roller, 24 mm, 45, both of them are construction line, 3 mm circle, same like last time, we'll eliminate this line and use circular pattern to draw 4 of them. Finish sketch and then cut all of them. So this is our connector part is ready. We will give it a name. So this is the connector part. We will draw a hole for the adapter. 3.1. $14 cut. So this is our connector is ready, and this connector, this is for the shaft. So new part, now we will use this wheel shaft, but I will draw it freshly here. $3.1 new component. 14 mm. $9 mm. 2.85. I need to modify this 5.6. This will be the shaft for the TT motor. Minus 8 millimeter. Many of the dimensions I have to go back because I'm just taking real life measurement with my slide calipers. Physical appearance, I will give it yellow color. With dark gold yellow. Component named TT motor shaft. So our parts are ready. Now is the time to assemble them. At the beginning of the assembly, the file need to be saved first. To saved, so I reached the limit of my editable document. I need to make one of them uneditable. There is only 10 document, 10 external design allowed at any given time without the paid subscription. This time it should work. Give it a name. Omni assembly. You can drag and drop file unless it is saved in this way. So the first part I will drag this connector. Now the first thing I would do is ground this part so that it is static. As you can see, the option I choose ground. The next part is this Omni frame. I'll choose this one. Just drag and get it out from the inside the part. Then I will make it in an angle where it is possible to choose the joint. So in this case I have more better visibility. I can see some of the sketches is still visible. So I will turn the visibility off. Sketch visibility off. Now we'll copy this part and paste for the second copy. As you can see, the second copy is just pasted inside the part. So I need to take it out. So this is the optimum angle. It will help me to choose the joint feature. Okay. Now with the joint command, I'll check the center of the screw hole. Now need to flip. As you can see, it has aligned perfectly with all the 4 screw fixtures. Okay. Now the second one. Joint. No. Flip. Okay. Now as you can see, the job is almost done. Now this roller pin, same like last time, drag and drop, and make sure the parts is not inside in another part. Then get it in optimum angle. Again. We need this roller joint as well. The roller joint, you can see the sketch, so I turn off the sketch visibility. I will copy this because that need to be both sides. Flip. As you can see, just flip this side. Now the other one. Okay. So this is the current condition. Let's zoom in. Minus 0.44. So we have some clearance. We can see the joint visibility, so I'll turn off the joint visibility just for better presentation. Now we will copy the pattern, copy the part in a pattern mode. So pattern, circular, not bodies, these are components. So which is this component, roller joint second, axis, it's gonna be this axis. We need 8 of them. So as you can see, our wheel is completed. Now we will put the wheel shaft. This wheel shaft is for it works as an adapter for the TT motor. As you can see, the TT motor shaft goes in and the other side get connected with the Omni wheel. So flip. Okay. Now to drag the TT motor. As you can see, for some reason, the location of the TT motor is far beyond. So this is the Omni wheel, as you can see, barely you can see, and the TT motor is there. So if we just drag it close, that looks alright. Zoom in. We'll copy this circle with this circle. Get the part a little bit closer. Minus 0.44. I need to get it more out, so I will just edit the joint, get the better visibility. So minus 22 seems appropriate. Yes. Now I will do a presentation from design, new drawing from design. Full assembly. Okay. I did a mistake. I'm supposed to choose A2 regardless. So I will get shaded view with northeast isometric, and the scale should be 2:1. Okay, then the next view, let's check the projected view. It is angular, so I'll just create another base view. This time slightly bigger, 1.5 to 1. Seems alright. And visible edges. Then print. We can print it in a PDF format. You also can change the paper size as well. So like this one is printing in A4 size paper. You can change the paper orientation as well. So I will keep it in landscape. Microsoft Print to PDF. Current sheet. A4 print. So I have already done the pre-printing. So this one I will give a Mecanum well. I don't know if my spelling is right or not. So I'm keeping C. As you can see, the full drawing in a presentation format. You can modify this according to your need. That's all for today. I will leave the file in the comment box. So please do not forget to like, click, subscribe, and share. I'll see you at next time. Thank you.